All right, welcome. Today, we are stepping into the world of these massive industrial plants. Those sprawling complexes that just look incredibly complex from the outside. But what if I told you there's an invisible line, a really simple concept that brings perfect order to all that chaos? Okay, let's dive right in.
I mean, just try to imagine building, budgeting, and running something like this. Where does one part even end and another begin? Who's responsible for what? How in the world do you even start to calculate the costs? It really seems impossibly complicated, but the engineering world, well, it has a surprisingly elegant solution.
And here it is. It's the concept of battery limits. Now, this isn't a physical wall or anything like that. It's an imaginary line drawn on a blueprint. And this one line is pretty much the secret to managing the entire project. It's the fundamental organizing principle that divides the whole plant into pieces you can actually understand and manage.
And this simple line does a surprising amount of heavy lifting. First, it creates a super clear physical boundary. Done. Second, it's absolutely crucial for accounting. It separates the costs that are directly tied to making a product from all the general infrastructure costs. It also makes it crystal clear who's responsible for operating and maintaining the equipment. And finally, it tells engineers the exact scope of their design work. It's all about creating clarity.
Okay, so let's take our first step across this line. We're going inside the battery limits, right into the core of the plant, which is known as ISBL. You should think of the ISBL area as the kitchen of a giant restaurant. This is where the real magic happens. It's where the raw ingredients are transformed into the final dish. This whole zone is dedicated purely to the main event, production. So the most important point here is that everything inside this boundary is directly involved in the chemical process. This is where you'll find all the major pieces of equipment, like the reactors and distillation columns. And because of that, the costs tied to ISBL are direct costs. That's the money you spend specifically on the machinery that actually makes your product. The focus is singular, efficient manufacturing. But, a kitchen can't run without a dining room or electricity or plumbing, right? So let's step back outside the battery limits and check out the essential support system, the OSBL. So if ISBL is the kitchen, then OSBL is pretty much everything else. The building itself, the storage rooms, the power supply, the roads leading to it. It's all the critical infrastructure that allows the core process to function, even though it isn't directly mixing the ingredients. Here in the OSBL, you find the utilities, the admin buildings, the roads, those giant storage tanks, and cooling towers. These are all considered indirect costs. And a really key feature is that these resources are often shared across multiple production units. The OSBL supports the entire site, not just one single process. Okay, so now we have these two really distinct worlds, ISBL and OSBL, and they're separated by our imaginary line. Let's put them side by side to really nail down the differences. And right here, the contrast becomes brilliantly clear. ISBL is all about core production. Its costs are direct, and its design focus is on making that process as efficient as humanly possible. OSBL, on the other hand, is all about support and utilities. Its costs are indirect, and the design focus is on site logistics and shared resources. So you have two different functions, two different cost structures, two different design philosophies, but they're all working toward the same goal. This distinction has huge financial implications. When you're budgeting for a massive project, you have to clearly separate the direct costs of your production equipment, that's the ISBL slice of the pie, from the indirect costs of all the supporting infrastructure, which is your OSBL slice. If you misjudge this balance, it can sink a project before it even gets off the ground. So, we've established that this line neatly divides the plant. But why is understanding and, more importantly, integrating these two worlds so absolutely critical for success? Well, because they aren't truly separate. Not at all. They are completely codependent. A brilliantly designed ISBL process unit is totally useless if the OSBL can't provide enough cooling water or electrical power. And a massive OSBL infrastructure is just a waste of money if the ISBL units aren't designed to use it efficiently. Success really lies in the handshake across that battery limit. This integration really boils down to a few key best practices. First, you have to optimize the layout so materials can flow efficiently from OSBL storage right into ISBL processing. Second, you have to perfectly coordinate your utilities. The OSBL supply has to meet the ISBL demand, no question. And critically, you have to integrate safety systems. An emergency doesn't care about battery limits, so your response plans can't either. So the key takeaway here is this. What starts as just a simple line on a drawing becomes the organizing principle for technology, for finance, and for people. It really proves that sometimes the most powerful tools are the simplest boundaries. It kind of makes you wonder, where else in our lives do we draw a simple line that defines two completely different but totally interconnected worlds? Something to think about. Thanks for tuning in.